This video, like several upcoming tutorials, will be in two parts. First, we'll introduce a new concept and then we'll put it to use in our platform game project. In this tutorial, you will learn how scripts connect to your objects and control them, how they inherit from other scripts, and then we'll create our character and give it some basic movement. So you can see the result right there. That's what we're going to get by the end of the video. A character that moves horizontally with acceleration and deceleration. That's basics for our game, and you can see the code right there. You'll find some companion files in the video description. I'll put them up on GitHub or something like that. And for the purpose of this video, you will need to create a new project. I went ahead and did that. There we go. Yeah, no problem. So we have an empty scene to start with, and we just have to do a little bit of setup work to get it working. So I'll add a node called world, and then a kinematic body 2D. That's going to be the skeleton of our playable character. The kinematic body 2D works with physics, basically. It will allow us to use collisions and to control our character. I'll rename it to player. And note the naming convention in Godot, it's Pascal case. So every word starts with a capital letter for objects or nodes. If I were to call it the main player or player main, I would give main a capital letter. Okay, so we have our player, and to be able to visualize it when we play our game, we'll need to add a sprite node. Look for sprite in the search bar and add a sprite. So that's the node that's responsible for displaying pictures on the 2D world. By default, in your resources on the left, you will see you have one image, the Godot icon. So we're going to use this one. Select the sprite in the scene tree, and then click and drag the icon to the texture slot. You will see it highlighted with a thin orange line. And when you drop it, boom, our character appears in the game world. I'll then select my player again, press the W key to call the move tool, and move my sprite to the middle of the scene. There we go, we are set up. I'm going to save the scene now by pressing Ctrl S, and I'll call it the world. It's our game world. And now let's just check if we test the game. For me, I already set this scene to be the one used by default by Godot, but if you haven't already, Godot will ask you to choose it, okay? And there we go, we're set up, we can get going. Now we want to add a script to our character, to the kinematic body. So right-click on it, add script, and then I'll just enter the path. I'll call it player.gd. There we go. You can click on create, and there we are, working on our script. So you can remove the comments that are there by default. We'll just leave the ready function. And I've mentioned it really briefly in the past, but the extends keyword is at the start of every script in GDQuest, and it tells Godot which class this script, which is a class in itself, inherits from. Okay? Our kinematic body 2D object is going to inherit from kinematic body 2D, which is going to inherit from the node, objects, and like physics body 2D, so it will give us a lot of functions to work with, like to move the character and all that stuff. You can search for the classes themselves, like if I type kinematic body 2D, you can see all of the inheritance hierarchy right there. So we have kinematic body 2D at the bottom of the list. I'll just write its name fully, so we only have the class hierarchy for this object. And there you go, you can see it inherits from physics body 2D, collision object 2D, node 2D, etc. up to object. So it has all of the properties of all of these classes. Now you can extend from a base class from the engine, like kinematic body 2D, and you will just have to write its name, or most of the time, Godot will write it for you when you create the script. But you can also extend from another script file from your own GDQuest file. Let me show you how. I'm going to do a bit of wizardry behind the scenes. There we go. So now I have a second script called baron.gd. In my player script, I can just type extend baron.gd. Because they are in the same folder, it's going to work. I can try out the game and I won't get any errors. So there you go. That's how you inherit from another file. Then I'll delete the file. There we go. We're ready to get working on our GD script. Now we have a few core functions to look at, which you are going to use all the time. So you know that a game works in a loop. Your code is going to run 30 to 60 times per second most of the time. And every time there's a new image that appears on screen, things have moved or whatever, it means that Godot has processed all of your game logic, all of your scripts, and it's going to use key functions for that. The most important one is called process. In order to call this one, we have to tell Godot that we want it to process the script on every single frame. So we'll add that instruction to the ready function. We'll just type set process, and then we'll use the boolean true to say set this script to process on every frame. So now we have to add the function process. And Godot is going to fill in a parameter called delta, and that's the time interval between two rendered frames, because it doesn't render frames at the same speed, although it will display them at even time intervals. I'll just add the pass instruction, not to get an error, and there we go. When the game loads, Godot is going to look at your ready function. It's one of the first ones it will look at. And it will see the instruction set process equals true. It's going to then take a note. Okay, on every single frame, I have to look at the process function and run all of the code that's inside of it. There's another built-in function that can be useful. It's called fix process. So we can tell Godot to use it by calling set fix process. The thing is, with process, the time intervals will not be even, but if we add the fixed process function, Godot will do its best to call it at even time intervals. So that's generally where you do physics, for example. But we won't need it just yet. We'll work with the process function for now. We can remove set fixed process. And that's all of the built-in functions we'll look at for now. There are more to work with, but we'll look at them in future videos. For now, we will get started coding our game character. Here's what we want our character to do. We want it to respond to using the left or the right arrow, and we want it to accelerate smoothly and decelerate smoothly when we release the key. There's a little extra. Our character will slow down when it changes direction. So let's see how we can do that. We'll need a few variables to start with. These are going to be the parameters that are going to control how our character moves. First of all, it can move to the left or to the right. So I'll add a variable called direction, and it will be an integer. It will be equal to 0, 1, that's going to the right, or -1. Then we need some speed variable. Same thing, I'll set it to 0 by default. This is going to be the speed of the character, regardless of the direction. So if it's going at 200 pixels per second to the left, the speed will be 200. 200 pixels per second to the right, the speed will be 200 as well. And the direction will allow you to modify in which direction the character is moving. Then we'll set the max speed as a constant. We'll use the keyword const, and it's going to be 600. Note how I typed it. It's a convention. You use caps to write the words and separate them with underscores so it is still readable. Then we'll need some acceleration and deceleration. I'll just copy these real quick. There we go. Now, trust me on that one. We need a variable called velocity, and we'll talk more about that later. But basically, we're going to work with vectors, and our speed is not going to be a vector. It's not going to be a piece of information that allows us to move our character. For that, we need to combine the speed, the time it takes to render the frame, and the direction all together into a horizontal vector that's going to tell Godot, okay, move this character by, I don't know, 20, 25, 30 pixels on this very frame. So now let's get started. First of all, we need to work with our input. We need to listen to the player's input. We'll talk more about it in the next video because input is the topic for next week. Just follow along for this time and trust me, I'll explain everything in due time. So we'll start with a condition. If input.isActionPressed, that's how we detect that a key is pressed. And we'll use UI left. That's the left arrow by default. That's some default input that's defined by Godot. If the action pressed is UI left, if the player presses the left arrow, we want to set the direction to -1. I told you that's the left direction. Elif, the input is UI right. We want to set the direction to 1. And the thing is, we need to handle the case where the player doesn't use any key. If none of these keys are pressed, direction is going to be set back to 0. There we go. Now we need to work on our speed. I told you I want us to use acceleration and deceleration. So here's how we're going to handle both cases. If the player presses the left or right arrow, we want the character to accelerate. And if the player doesn't press any arrow, we want the character to decelerate. How can we check that? Well, using the direction. Because if the direction is set to 1 or -1, it means that the player is pressing either the left or the right arrow. We can use the condition if direction. If direction is something other than 0, that's what that means, 0 or false. If the player is pressing a key, the speed is going to gain. We're going to add acceleration times delta to the speed. So let me explain that. First of all, the plus equal characters mean add what's on the right to the variable on the left. We are going to add not just the acceleration, but acceleration times delta because it's the time interval between the last 2 frames. That's how we make the motion smooth. We accelerate it for a certain amount of time only, right? Else, we're going to subtract deceleration times delta. And I made a mistake here. Acceleration should be like that, and it should be a constant, and then deceleration as well. So that's not enough just yet. We want to do a little something more. To see that, we are going to give acceleration and deceleration some values. So I'll use 1000 pixels per second for the acceleration and 2000 pixels per second for the deceleration. We'll just add 2 lines of code to control our character's movement. We'll set the velocity to speed times delta and multiplied by the direction. And then we'll move the character using the move method by a vector2. This function needs a vector2. We'll talk about vector a bit later. And we'll use velocity for the x component of the vector and 0. And now if we try out the game, oh, it's all messed up. Why is that? Well, it's because our speed can go up and down to any value. So we need to use a little handy function called clamp. We're going to write this instruction after the speed has been modified. We'll call the clamp function. So we'll set speed to clamp itself, speed, between two values, which are 0 and max speed. The clamp function is going to take the speed value, the first parameter, and if it's below the second parameter, it's going to clamp it to it. So if speed is lower than 0, it's going to be set back to 0. And if it's higher than max speed, it's going to be set back to max speed. Let's try our game again. And it works. It now finally works. Now we have one little problem left. Look at what happens if I press the right key or the left key. What happens when I stop? The character stops right away. And what do we want to get? Smooth deceleration. The reason for that is because whenever the player stops pressing the left or the right arrow, we set the direction to 0. And then we use that direction to calculate our velocity. So as soon as you release the left and right arrow keys, velocity will be set to 0, so the character will stop moving. We need to handle not only the input of the player, but also the last direction the character was in. We could rename direction to input direction and then just add a variable called direction. We need to replace these instances of direction by the input direction variable. I'll press Ctrl R to call the replace tool, and I want to replace direction by input direction. I'll select the area of the code in which I want to replace that variable, check selection only, so it's only going to modify down there, and click on replace all. There you go. And now we need to do a few extra things. We need to set the player direction to the input direction. Okay, but we not only need to do that because we need that to always be equal to 1 or -1. We don't want it to be set to 0. So to do that, we're going to add the if input direction condition again. You'll notice one thing. We have the same condition twice in our code. I'm using the same condition at the top and at the bottom. Technically, I could put this instruction right below speed plus equals acceleration times delta. But I won't do that. And the reason is I want to keep my code organized. You don't have to worry about performances, like limiting the amounts of instructions and all in simple games like these. Instead, it's much more important to keep your code readable. So here, I have everything that's input related. And then down there, I have the actual calculations that allow the character to move. And I don't want to get them mixed up. So now we have our direction, which we're going to use for the velocity. And now if we try out the game, when you release the key, your character smoothly decelerates until it stops. That's how you create good motion for a side-scrolling platform game. And then you'll just have to play with max speed, acceleration, and deceleration to get the right feel for your game. But that's polishing, and that's something we'll look at later, towards the end of the project. I want us to add a little extra thing. When I change direction, the character keeps its speed, and it's really strange. For some games, it's going to work fine, especially if you don't have acceleration and deceleration for a much simpler platform game. But we want the character to slow down when it changes direction. So we can add a condition for that. If, I'll put it in the movement section of the code, if the input direction and our character's direction are opposite, we'll divide the speed, you can type divide equals, by something like 2 or 3 maybe. There we go. And you can try out the game. And now the character slows down and it makes for a much more natural movement, something a little more realistic. And that's it for this video. Thank you for watching. Please leave a like, it makes a huge difference for the channel. And in the next video, we'll look at input, which is very important in platform games, but not only. And we'll then progressively explore new tools in Godot.